Okay, welcome back. Hopefully this works and I don't record this video for nothing. So let's jump right into where we left off last time in lab. We're going to look at number 5 from 1.11a, where we're using Pascal's triangle and the binomial theorem. So let's look at number 5. We have this x plus 4 to the x plus 2 to the fourth power. And what we want to do is use the binomial theorem to multiply this out. Now, of course, we can always write this out as black pen. We can always write this out x plus 2 to the fourth as x plus 2 times x plus 2 times x plus 2 times x plus 2. And we could do that and then multiply all of this out manually, but the reason we want to use the binomial theorem is because it will be much quicker once we get the hang of this. And so how I like to do this, personally, is first we have to identify from Pascal's triangle which coefficients we want to use. So everyone should have this by now. So this is Pascal's triangle. And since we're raising this to the fourth power, we want to use tier 4. And so our coefficients for our binomial expansion are 1, 4, 6, 4, 1. And so with that in mind, we can say that this is equal to 1 times x times 2. We have to identify what, and it looks like my camera doesn't want to focus. Okay, see if that fixes anything. So we want to, so we're using our binomial coefficients. Again, that was 1, 4, 6, 4, 1. So we start off with 1, and we want to identify what a and b are in our binomial expansion. So a here is x, and b here is 2. So we have a and b, in this case, x and 2. And then I'm just going to write this all out first. So this is going to be 4 times x times 2 plus 6 times x times 2 plus 4 times x times 2, and then plus 1 times x times 2. So with all of this, now we just need to write what the exponents are. So on the back of this sheet, I did print off the binomial expansions, like their full formulas. And while I think this is handy to have, you really don't need it once you understand how we derive a lot of these formulas. So remember that the coefficients are determined by Pascal's triangle. So we're looking at tier 4, and we have coefficients of 1, an implicit 1 here, 4, 6, 4, and 1. And then look at a and b. The exponents for a starts at 4, so whatever this number is, 4, 3, 2, 1, and then 0. So this a here, remember anything to the first power is itself, so a to the first power is just a. And then a to the 0th, anything to the 0th power is 1. So we don't even need to write a to the 0th, we just write b to the 4th. And then same thing with the b's. Notice that it starts with 4, starting backwards, 4, 3, 2, 1, and then 0. So if I write out the exponents here, if this is a and this is b, we're going to start with 4, 3, 2, 1, 0. And then with b, we start at 0, 1, 2, 3, 4. So again, things to consider. Anything to the power of 0 is 1, so we don't need to write that. So I'm going to cross that off right there, and the x to the 0th as well. And we really don't need anything to the power of 1, because to the power of 1 is just itself. So I'm going to erase that, and I'm going to erase that as well. So really, and also we don't need to multiply by 1 explicitly. So really, all we have here in this first term is x to the fourth. And so for this first term, we just have x to the fourth, and then that was it. We crossed off our 1, and then our 2 to the 0th didn't matter either, because both that's 1 and this is 1. So x to the fourth. The next term we have is, we have 2 to the first, which was just 2. So 2 times 4, which is 8. And then x to the third. Next term we have, my camera, why is it not focusing? Okay. Next term we have is 2 squared, which is 4. And then times 6 is 24. So 24, and then x squared. Next we have 2 cubed, which is 8, and then times 4 is 32. And then times x. And lastly, we have, these two terms, or factors, went away. They're just 1. And then 2 to the fourth is 16. So we have plus 16. And so this is our final answer. What's nice is that this stayed in standard form for us, so we don't even have to rearrange it or anything. This is what we have for the answer for number 5. Next up, we have number 6, x minus 3 to the 5th power. So let's write that one on. Write that out. X minus 3 to the 5th. Let's see, so x minus 3 to the 5th. So again, we could multiply all that out manually, but that's not going to be very efficient. So what we want to do instead is use the binomial theorem. And so first we have to identify what are the coefficients we have for Pascal's triangle. So since we're using the 5th, or we're raising something to the 5th power, we have to use tier 5. So we have 1, 5, 10, 10, 5, 1. And now let's construct this. We also have to identify what a and b are. In this case, we have a is x and b is negative 3. So we have 1 times x. I'm going to have to write this a little bit smaller because this one gets a little bit long. X, negative 3, 5 times x times negative 3, plus 10 times x times negative 3, plus 10 times x times negative 3, plus 5 times x times negative 3, and then plus 1 times x times negative 3. Okay, just barely. And then with a, we start with a power of 5. We have 5, 4, 3, 2, 1, 0. And then b, we start with 0 and count up. So we have 0, 1, 2, 3, 4, and 5. And remember, we don't need anything to the power of 0. We don't need that 1. First power is redundant. Also first power over here. And then we don't need this 1 or the x to the 0th because those are both 1 as well. So really, all we have here is x to the 5th, which is, well, just x to the 5th. The next term we have is negative 3 times 5, which is negative 15. And then x to the 4th. So x to the 4th. Next we have negative 3 squared, which is positive 9. And then times 10, it's going to be positive 90. And then x cubed. Next we have negative 3 cubed, which is negative 27. Times 10 is going to be negative 270. X squared. Then we have negative 3 to the 4th, which is going to be positive 81. And then 81 times 5 is 405. And then that's times x. And lastly, we have negative 3 to the 5th, which is negative 243. And so, we're already done. This is our final answer. The hardest part about doing any of these is setting it up. But once you have your binomial expansion set up, it's actually pretty straightforward to multiply everything back together. All right, let's try the next one. The next one we have is 2x plus 1 to the third. So 2x plus 1 to the third. We have to look at what coefficients we have. Since we're raising something to the third power, our binomial coefficients are going to be 1, 3, 3, and then 1. So let's see if we can do this without actually writing out these terms here. The first thing we're going to have is just whatever this thing is, a, 2x is cubed. So we just have 2x cubed. Now our next coefficient is 3. That one we're going to have as 2x squared, and then times 1. So I'm still going to write that 1 out here, just to be consistent. The next coefficient we have is 3. This one's going to be 2x to the first, so we don't need to write the exponent. However, our b here, 1, is going to be squared, even though that'll be simplified to 1. And then the last thing we have for the last term, remember we have a leading coefficient of 1, and then this 2x is to the 0th, so we don't even need to write that. And then we just have 1 cubed. So 1 cubed. And if we simplify all of this, remember, anytime we raise anything in parentheses to a power, we have to raise anything being multiplied inside the parentheses to a power individually. In words, we have to cube 2 and we have to cube x. So 2 cubed is 8. X cubed is, well, x cubed. We really don't need this 1 here, so all we have to worry about is 2x squared. So we square 2 and then we square x. So 2 squared is 4, and then 4 times 3 is 12. So this gives us 12, then x squared. The next one we have, don't really need that because it's just going to be 1. We have just 3 times 2x, which is going to be 6x. And then the last term we have here is 1 cubed, so 1. And this is our final answer. Next one we have is 3x minus 2 to the 4th. So 3x minus 2 to the 4th. Again, let's see if we can write that without writing out all of the unnecessary information. So our first term, first we need to identify what our coefficients are going to be. So for the 4th tier, we have 1, 4, 6, 4, and 1. And because we have a leading coefficient of 1 for the first term, that's going to be just 3x to the 4th. And we don't need to write the minus 2 to any power because that's going to be the 0th. So it's just 3x to the 4th. Next number we have is 4 times 3x to the 3rd, and then times negative 2. Next coefficient we have is 6. We have 3x squared, and now negative 2 is squared. Something to note, by the way, is that your exponents always add up to whatever this number is. So this is a 4, and remember, negative 2 here is going to have an exponent of 0, so 4 plus 0 is 4. This has an implicit exponent of 1, so 3 plus 1 is 4. 2 plus 2 is 4, and that can be seen on any of the other ones that we were doing as well. The next term we have is 4 times 3x. That's just going to be to the first, but the next thing is the negative 2 to the 3rd. And lastly, we have negative 2 to the fourth. So simplifying all of this, we have 3 to the fourth power, which is going to be 81 x to the fourth. Next we have 3 cubed, which is 27, and then times negative 2 is going to be negative 54, and then times 4 is going to be negative 216. And then we have this x cubed, so negative 216 times x cubed. Next thing we have is negative 2 squared, which is positive 4. And then we also have 3 squared, which is 9. So we have 9 times 4, which is 36. And then we have times 6. And 36 times 6 is going to be positive 216. And then that's going to be an x squared. Next, we have negative 2 to the third power, which is negative 8. Negative 8 times 3 is going to be negative 24. And then times 4 is going to be negative 96. And then that's just times x. And lastly, we have negative 2 to the fourth, which is going to be positive 16. And so we have our final answer here. Okay. Now, the next set of problems that we want to do, we want to find a given term of a binomial expansion. So let's look at x plus 5 to the fifth first. X plus 5 to the fifth, we want to find the third term to this. So how we can do that is first we look at our triangle. Since we're raising this to the fifth power, we have 1, 5, 10, 10, 5, 1 as our coefficients. And the third term is just going to correspond to 1, 5, 10. So it's whatever this term is here. So we already know that that's going to be a coefficient of 10. So for the third term, we don't need to calculate the whole thing, we just need 10. We have x, and then we have 5 as our a and b, and now we just need to figure out our coefficients. Sorry, not our coefficients, our powers. So remember that x here, a, is going to start at 5. So if this is starting at 5, this is going to be 4, and this one's going to be 3. So x is going to have a power of 3. And for 5, well, remember, you can either count up like this, so you can start at 0, 1, 2, and determine that that's going to be 2, and that's fine. Or you can remember that these two always have to add up to 5. So if you know that this one is 3, 3 plus what gives us 5? 2. So 2 different ways that we can do that. Either way, we have 5 squared, which is 25, and then times 10. This is going to be 250. And then we have x cubed. And so this is the third term of x plus 5 to the fifth power. All right. What about x minus 2 to the seventh power? We want to find the fourth term. So for the fourth term, first we have to identify what our coefficients are. So we look at tier 7, and since we want the fourth term, we have first, second, third, fourth term. So our coefficient here is going to be 35. We have 35 times x times negative 2. And for the fourth term, let's see. So remember, this starts at 7, and then 6, 5, and 4. So 35, 35 is our coefficient, and a is going to be raised to the 4th power. And since this is a 4, we don't even need to look at Pascal triangle anymore because 4 plus what number gives us 7? That would be 3. And then that already tells us everything that we need to simplify. So we have negative 2 cubed, which is going to be negative 8. And then negative 8 times 35. My brain is not big enough for that one to do off the top of my head. So just calculator here. We have negative 8 times 35, which is going to be negative 280. So we have negative 280 times x to the 4th. And so that is our 4th term. Next one we have is we want to find the 5th term of 3x minus 1 to the 8th. So what was that again? 3x minus 1 to the 8th. And we want to find the 5th term. So for the 5th term, let's see. There is kind of a shortcut that you can do instead of looking at the triangle. Well, I mean, you look at the triangle for your coefficients. So for the 5th term, it's this is 1st, 2nd, 3rd, 4th, 5th. 5th term is going to have a coefficient of 70. So 70. And then we have 3x and negative 1. But what if we wanted to figure out this the exponents without looking at the triangle and counting? Well, what we can do is this is to the 8th. We're trying to find the 5th term. 8 minus 5 is 3. Add 1 is 4. And this works for every single one of these. 7 minus 4 is 3, plus 1 is 4. 5 minus 3 is 2, plus 1 is 3. So if we know that this is going to be 4, we also know this one's going to be 4 as well. And so we have negative 1 to the 4th is just going to be positive 1. 3 to the 4th power is going to be 81, and then times 70. Again, I'm not going to be able to do that in my head. But we have 70 times 81, which is 5,670. Yeah, that I would have never gotten that in my head. So 5,670 x to the 4th. Last one we have is 2x plus 3 to the 4th, and we want to find the last term. So 2x plus 3 to the 4th. Last term. So if we're told the last term, how do we know how many terms it's going to have? Well, notice that the number of terms you have is equal to whatever your tier is plus 1. So tier 0 has 1, tier 1 has 2. If we look down here at tier 6, 1, 2, 3, 4, 5, 6, 7. So if we're looking, we want the last term of this expansion. How many terms do we have? Well, if this is 4, plus 1 is 5. So really, this wants the 5th term. And if that's the case, then all we really need is first, we can either recognize that the very first and the last term are always going to have a coefficient of 1, or if you would like to verify that on your triangle, since we're raising something to the 4th power, we have 1, 4, 6, 4, 1, so coefficient of 1, and then times 2x and then times 3. And we can do 4 minus 5, which is negative 1, plus 1, which is 0. And then that means this number has to be 4. And so even if we look at the expansions, that should make sense because anything to the binomial to the fourth power, it's just going to be b to the fourth power. And as mentioned earlier, anything with zeroth we don't need because that's just 1, and this is a 1. So really, we're just trying to figure out what 3 to the fourth power is, which is 81. And so that is our final answer. Let's look at the next page. Now we're doing our favorite part of any of these assignments, test prep. We want to figure out the leading coefficient of the fourth term when this is expanded. So, leading coefficient of the fourth term. So, it's not just asking for the coefficient on your triangle. We actually have to calculate out what's going to happen because of this negative 2. However, if we look at our triangle, we're looking at tier 6, and we want the fourth term. We have 1, 2, 3, 4. So this is going to be 20 for the coefficient. We have x and negative 2. And then for the fourth term, we have 6 minus 4, which is 2, and then plus 1 is 3. And so the other number here, 3 plus what gives us 6? That's also going to be a 3. And when we calculate this out, this is going to be negative 2 to the third power, which is negative 8. And negative 8 times 20 is negative 160. And then we have our x cubed. And when it's asking for the leading coefficient of the fourth term, that's just this number right here, the negative 160. And so our answer is A. What is the second term when 2a minus b to the fourth is expanded? So it might look a little bit different now because now we have a variable and a variable, but that's okay. So first, look at our triangle. So we're looking for the second term, and we're raising something to the fourth power. So we look at tier 4, and first term, second term. So our leading coefficient is 4. Then we have 2a and negative b. I know that looks a lot like a 6. Hold on, let me fix that. B. And since we're trying to find the second term, we have 4 minus 2, which is 2. And then this is going to be a 3. And then, well, that means that this has to be a 1, but really we don't need to write that. So let's figure this out. We have 2 cubed, which is 8, and then times 4, it's going to be 32. Then we have an a cubed, which is just going to be a cubed. And then we have negative b. Stick a negative in front, put our b. And so that gives us also a. And I don't know if you can hear my cat. Hi, kitty. Yes. So that's number 14. And now the last one, we have 15. Let's see. In the xy plane, the graph of a function f has the limit of f of x as x approaches positive infinity is equal to positive infinity. What's following could be an expression for f of x. So what is that saying? It's basically meaning, because as x goes towards positive infinity, we should note that that really means the end behavior. As x goes way out to the right direction, so as we go really far that way. Okay, and we want this function, as x goes really big, we want f of x to go to positive infinity, so it needs to go up as we go this way. So which of these could do that? Now this isn't directly related to this section necessarily, unless you want to multiply out the x plus 3 cubed and x minus 1 cubed, x plus 2 cubed, okay, and x plus 3 cubed as well. But there's a way that you can find this without even using the binomial theorem. First, let's just look at the types of functions we have here. First, we know that if we multiply a, or answer choice A, if we have x plus 3 cubed, our leading term is just going to be an x cubed term. So this is going to be x cubed plus some stuff divided by x times x cubed plus 1. So really that's going to be x to the fourth plus x, but we don't really need that when we're trying to figure out the end behavior. Really, we should just notice that we have x cubed over x to the fourth, and anytime we have the denominator being the dominant polynomial, that means that the end behavior is going to go towards 0. This means that we have a horizontal asymptote at y equals 0. So a can't be correct because our function needs to go up towards positive infinity. The next one we have, this is a polynomial. Now we can multiply all of this out. However, notice that this is going to be an x cubed here. So whatever we multiply this out to be, it's going to be negative 2 x cubed plus some stuff, and then times x. And if we multiply that together, it's going to be negative 2x to the fourth, approximately. Because we have some stuff left over here, but it's not going to really matter, because when we're looking at polynomial end behavior, the other terms don't really matter. We just need that leading term, so it doesn't matter what the other stuff is following it. And if we remember from our polynomial end behavior chart, that a polynomial with a negative leading coefficient and an even degree is going to have end behavior that looks like this. And so neither of these are going, as we go to the right, it needs to go up. This one is going down. So B cannot be it. The next one is similar to A. We have x. This is going to be, I'm running out of room here. We have an x and then times x plus 3 cubed. This is importantly going to have an x cubed term that we're multiplying in there. So that's going to be x to the fourth when we multiply that with x. And the bottom one is going to be x times x cubed plus 1. That's going to be x to the fourth. And then plus an x. And this one's going to be plus some stuff. And then this is going to be plus x. But really, we don't need any of that. We don't need any of that. Really, you just want to recognize the leading terms here. We have x to the fourth over x to the fourth. Since these have the same degree, we're going to have a horizontal asymptote at whatever the leading coefficients are here. And really, we have 1 over 1. So 1 over 1 is just 1. And we have a horizontal asymptote there. So by process of elimination, we can already conclude that this has to be D, and let's see why that is. So for x here, we have x plus 2 cubed, and that's going to give us some x cubed plus unimportant information, and then times x minus 1, but again, unimportant information. And really, this is going to be approximately equal to x times x cubed times x, which is going to be x to the fifth. And if you remember, this has a positive leading coefficient of particularly 1. So positive leading coefficient and an odd degree, that's going to have end behavior that looks like that. And so we can see that as we move further to the right, our function keeps going up. And so that is in line with this type of end behavior. And so that is why D is the correct answer. And so that is all for this practice. I wanted to make sure that everyone, um, had time to review this. So yeah, that concludes that. We did the rest of the practice, problems 1 through 4 in lab. So, yep. Thank you for watching.